Okay, we're solving with logs on both sides. This is part 2. I'm just continuing from the last lesson, just going with some examples. So example 1. Let's say we have log base 2 of x minus 8 equals 2 plus log base 2 of x minus 5. Okay, so to remember, move the logs to one side. So if you want to pause this and try it based on our first example, you can. There's a different process in this problem in the middle, just because of our rules of logs. But if you want to go for it, by all means, go for it. So it is a plus. I want to move the log to one side. So I'm going to because this is a plus log base 2 of x minus 5. I'm going to subtract that from both sides. So we get a log base 2 of x minus 8 minus log base 2 of x minus 5 equals 2. And now we have to condense this right as a single log. And when there's subtraction, these two pieces turn into division. So x minus 8 over x minus 5 equals 2. So now we can write 2, the base, and we just switch those two. So this one here, we get 4 equals x minus 8 over x minus 5. If we're solving for x, we can't have an x on the bottom. So what we're going to do is multiply both sides by x minus 5. So we get 4x minus 20 equals x minus 8. And this one doesn't turn out to be a quadratic, it's just linear. So when we get our x's on one side, I'm going to subtract x from both sides, so I get a 3x. I'm going to add 20 to both sides. So I'm going to go plus 20, I subtracted x previous. Negative 8 plus 20 is 12. Divide by 3, x equals 4. Okay, let's look at our original problem. If I plug 4 into x, I get log of a negative. That means no good. So this answer doesn't work, and because there's nothing left on Alex, you would pick the no solution. So the answer we get doesn't work. There's nothing left, so there's no solution. I'm going to try to condense this a little bit. So number 2, you can try this one. Now we're going log base 4. But the same rules all apply, the same process. Okay, so I'm going to subtract this from both sides. If you want to pause it and try it, go for it. I'm going to continue on with the answer. So subtract that log base 4 from both sides. And I'm going to write this as a single log. So I get x plus 8 over x plus 5 equals 1. So 4 to the 1 equals x plus 8 over x plus 5. So I'm going to multiply x plus 5 on both sides. So 4x plus 20 equals x plus 8. Subtract x. So very similar to the last problem. Subtract 20. And x equals negative 4. So I subtracted x from both sides, and then I subtracted 20 from both sides. That's how I arrived here. Divide by 3. Now look back, negative 4. Negative 4 plus 8 is 4. That's good. Positive. Negative 4 plus 5 is 1. That's positive. That's good. So this answer does work. It does check. And our last problem. Log base 5 of x plus 2 equals 1 minus log base 5 of x plus 6. So if you want to pause this and try it, go ahead and do that. I'm about to continue on with the answer. So in this problem, we're going to add this log base 5 of x plus 6 to both sides. So we get log base 5. The addition turns into multiplication. So now remember we switch these two. So we're going to write this as an exponential equation. So 5 to the 1 power equals x plus 2 times x plus 6. 5 equals, I'm going to FOIL this out, x squared. We get a 2x and a 6x, which is an 8x, plus 12. Subtract 5 from both sides, and we get 7. And how does that factor out? What multiplies up to 7? That adds up to 8. It's 7 and 1. So x equals negative 7, x equals negative 1. Just set each piece equal to 0 and solve. Now plug back in the original. If I plug in negative 7 plus 2, that's a negative, no good. So that one doesn't count. If I plug in negative 1 plus 2, positive. Negative 1 plus 6, positive, that's good. So x equals negative 1 is our only answer to this problem. So that concludes the second part of this lesson.